Hola Khan Academy. My name is Corinne Kirkbride, and I'm actually a teacher at a community college in California. However, I am currently in Colombia doing a sabbatical, which is going to be for fall semester. However, I am on sabbatical to learn Spanish, so I left in June when my summer began so that I could get as much as possible out of the experience. Because of that, a couple things are difficult in order to be a part of your talent search. One is that I don't have a tablet with me, so I can't do your Khan style videos, but I have done them in the past with McGraw-Hill, although I don't own them, so I can't link to them. They are part of their online content that students have to pay for. So I'm hoping that it's okay, that you get an idea of my feel and my style and how I speak by seeing it on a board. I'm actually at the Spanish school that I'm taking classes at 4 hours a day, 5 days a week. But they're letting me use the room right now so that I can do a short video for you guys. I'm also going to link to one that I've done in the past about 5 years ago, 6 years ago, that I put up on YouTube and has a lot of hits, but understand that that was from a while ago, and I do consider myself to have improved over time. Today what I'm going to talk about is simplifying rational expressions, and we'll just recall what a rational expression is, and we'll do some examples of that. So this is a lesson that would be good for elementary algebra or kind of an intro in simplifying rational expressions in intermediate algebra, again at the community college level. So simplifying rational expressions. We want to remember that a rational expression is just when we place one polynomial on top of another polynomial. In the definition, we just refer to those as P over Q, and understand that what that means is simply that P is some polynomial, say x squared minus 5x plus 6, and we just place another polynomial underneath that, say x plus 5. The only thing we have to worry about is that q, meaning the polynomial that's in the denominator, cannot be equal to 0. And hopefully you remember that that's because if the denominator is 0, we'd be dividing by 0, and we know we cannot do that. So looking at this example, we can see that if the denominator were to be -5 for x, like if we were to say, let's let x be -5, that would give us a denominator that has 0 in it. So we are going to just say that x cannot be equal to -5. This allows us to say that this polynomial is true for any real number, but -5. And we'll talk about this in the future when we do solving equations and things like that. But for now, we're just going to simplify. So let's now take a look. Let's recall simplifying just fractions. So let's say I ask you to simplify 6 divided by 10. Now, a lot of you would say, I can see that there's a common factor in 6 and 10. And you'd be right. So think about what that number is that's common to both 6 and 10. Hopefully you're thinking 2. But a lot of people, a lot of students want to take that 6 and 10 and they want to divide it by 6 and they want to divide it, they want to take that 6 and divide it by 2 and take that 10 and divide it by 2. But let's think about it a slightly different way. We know that 6 is 2 times 3, and we know that 10 is 2 times 5. So by writing them out as factors, the things that we can multiply together to get 6, and the things we multiply together to get 10, hopefully we see that we have a factor in common, and that factor is 2. And then, just using properties of multiplication, I can separate the factors into the first factor, which for both of them I wrote as 2, and everything else. And we can see that we are left with 2 over 2 times 3 over 5. But understand that 2 divided by 2 is something divided by itself. And anything divided by itself is just 1. So this is 1 times 3/5, and of course 1 times anything is itself. So a lot of you could probably look at that and say, that's 3/5, and you wouldn't have to do a lot of work. But understand that this is the real process to doing that, and that's simplifying common factors. So we've simplified the common factors to get 3/5. Okay. Similarly, we could do 20g over 35. Very similar, except I have a variable in the numerator, which is g. But again, when we look at the numerator and denominator, think about the common factor there, common to both 20 and 35. There won't be anything common to g because it's in the numerator by itself. There's no other g's. We can see that they share 5. So we have 5 times 4g. That's simply 20g with my factor factored out. And 35 is 5 times 7. Again, we notice we have that common factor. Properties of multiplication allow us to factor it out. And 5 divided by 5 is just 1. 1 times anything is itself. So we've simplified to 4g over 7. So this should be familiar. People should understand how to do this kind of simplifying before we head into rational expressions, which is what I'm going to do now. As an example of a rational expression, we will do y squared minus 4 over 2y plus 4. Now, a lot of students have a tendency to just start crossing things out that they see that are the same. Very, very common. But understand that until you know what the factors of the rational expression are, there is no way that you can actually simplify them. So I often tell students, a lot of what we do with rational expressions, when in doubt, factor it out. Once you've done all your factoring possible, then you can look for common factors. So understand that y squared minus 4, 2y, and positive 4 are all just terms of the numerator and the denominator. They are not factors of the numerator and the denominator. So by factoring, we'll do the denominator first. Notice 2y and 4 share a common factor of 2. When we factor out the 2, we're left with y plus 2. The numerator has 2 terms as well. They don't share a common factor, but we recognize that we have something squared minus something squared. And we should remember and recall from when we learned about factoring that this is the difference of 2 squares. Meaning, we should have opposite signs, but other than that, everything else is the same. In order to get y squared, we need to multiply y times y. And in order to get 4, we need to multiply 2 times 2. Remember, you can always check your work by factoring out, by multiplying out what you factored to see if you come back to your original. However, we're not going to do that because our job is to simplify. So we take a look, we see that we have a common factor now that we factored. How many will see something in common? Numerator, denominator? Hopefully you're seeing y plus 2. Because of this multiplication that we have going on between the factors, we have y plus 2 over y plus 2, and we have a y minus 2 and a 2. So I can do the separation, it's not required, but it does allow you to see that you have a common factor, something divided by itself, and we're left with y minus 2 divided by 2. Understand that that is for anything that does not make the denominator 0, which when we look at this, we can see that y being negative 2 would give us a 0 in the denominator. It would give us 0 here, and 0 times anything is 0. So we do want to think about the fact that y cannot be equal to negative 2. But again, we talk more about that in the future. I'm going to do one more example. This is going to be a trinomial. Okay. So how many terms does a trinomial have? One more. And in the denominator, I've got another one. Polynomial in the numerator, polynomial in the denominator, so this is a rational expression. Again, don't fall into the trap of, I've got 2y squareds. I'm just going to cross those right out and they're gone. All you have right now are polynomials that are separated by addition and subtraction. These are all simply terms. You need to know what are the common factors. That's all that can be simplified. So in looking at this, we can see that it is not factored. We don't have the factors yet. However, from our factoring days, we know how to factor. Trinomials most commonly factor into two binomials. For something of this type, we see that we need two numbers whose product is -3 and whose sum is +2. We see that because our product is negative, our signs are going to be opposite. We know that to get y squared in the front, we need y times y. The only things that make up 3 are 1 times 3. And in order to have a larger middle number here, we want the larger number to be the positive. So we need +3 and -1. Another tip, which is really helpful, is to think about the fact that since your job is to simplify rational expressions, it's very likely to see some common factors. So as you're factoring, think about, do I end up with anything that is the same as one of my factors up here? Because right now you can see, how many factors do we have? Often very difficult for students, but we have 2 factors here, 1 and 2. Everything here is being multiplied by everything here. Denominator will most often factor into 2 binomials because we have a trinomial. We see that we have a 2 here, so we want the product of our 2 numbers that we need here and here to be a +2. We need here to have a sum be -3. Only 2 numbers that give us 2 multiplied together are 1 times 2. Because we have a negative middle term and a positive last term, we should have 2 negative numbers. It's the only way to multiply and get a positive here, but a negative here. And of course, since the only 2 that can make 2 are 1 and 2 when multiplied, we know we need 1 and 2. And to get that y squared, we still need the y's. Now you can probably see at this point, we have a common factor, and that is y minus 1. So we're going to recognize that y minus 1 divided by y minus 1 is just 1, and we're left with y plus 3 over y minus 2. And it can be a lot easier to see here that this is true for all values of y, except y cannot be 2 and y cannot be 1. If y is 2, this denominator is 0. And if y is 1, this denominator is 0. So we have our answer. So that's a basic introduction to simplifying rational expressions. Thank you, Khan Academy.